Hello everyone. In this video we're going to be simplifying a radical expression. We have the square root of 7 plus the square root of 1 plus the square root of 7 plus the square root of 1 plus so on and so forth. So this goes on forever, but let's go ahead and define it in a sequence way. So we're talking about a sequence that can be written like this. A sub n plus 1 equals the square root of 7 plus the square root of 1 plus a sub n, where n is greater than or equal to 1, and a sub 1 is defined as the square root of 7 plus the square root of 1, which can be written as the square root of 8, which can be written as 2 times the square root of 2. Great. So this is our sequence basically, and we want to find the limit of the sequence as n approaches infinity. And as you know, with these kinds of expressions, the answer is finite, so we can find the limit. We've done simple, easier versions of this problem. I think it was with square root of x plus, or just a single number. Think about it, like if you had something like this, you know, square root of 6 plus the square root of 6 plus the square root of 6, so on and so forth, and this goes on forever, defined in the same manner, then as you know, this would be a 3, right? It's easy to check, and I also gave you, I believe, a shortcut. If I didn't, please let me know. I can kind of talk about that as well. Anyways, so this is our sequence, but what makes this problem more interesting is that we have two different numbers that are kind of alternating, 7 and 1. And those numbers are very special. You'll see in a little bit why. Now, obviously, the solution of this problem is not going to be that simple because we're going to have to deal with more stuff. So let's go ahead and start by setting this expression equal to x. So what happens if you set this whole thing equal to x? Then obviously the next step would be squaring both sides and getting 7 plus the square root of 1 plus the square root of 7 plus the square root of 1 plus dot dot dot. I know some people don't want me to say dot dot dot, but I like to say dot dot dot. Anyways, so this equals x squared. And you'll notice that this expression contains itself. So from here on, we can just write that, okay, this is the same thing as x, including the square root. So we can write it as 7 plus the square root of 1 plus x equals x squared. Obviously, we didn't get a quadratic like in the other simpler case. We're going to be getting a quartic equation from here. But let's go ahead and isolate the radical first. Square root of 1 plus x can be written as x squared minus 7. And at this point, you might be guessing the solution. That's fine. We're just going to look at it from a more algebraic standpoint. Okay, let's square both sides. So let's just square this and square that. That should give us 1 plus x equals x to the 4th power minus 14x squared plus 49. Putting everything on the same side gives us x to the 4th minus 14x squared minus x plus 48 equals 0. Now, we're hoping to find some rational solutions to this, you know. So to find rational solutions, we're going to use the rational root theorem. So we're basically looking for factors of 48. Obviously, 48 has a lot of factors. I'm going to spare you the trouble. You can look through basically all the numbers like plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 8, plus minus 12, plus minus 24. I hope I didn't skip anything. And plus minus 48. Okay. So a lot of factors to check, and obviously this can be automated. You can use a computer to check it out, or you can do it manually. Long division, synthetic division, whatever division you want to use. But at the end, you're going to find, hopefully, a rational solution. And we actually do find a rational solution to this equation. And that solution is x equals 3. And you probably guessed that at this point, because when you look at this problem, hey, come on. If you replace some numbers, like x with some numbers, such that 1 plus x is going to be a perfect square, there aren't that many numbers to check. And as you know, as the numbers grow, the right-hand side is going to grow faster, so you kind of have to stop somewhere, right? After a while, you're going to get larger numbers on the right-hand side. So you can tell, you can find the solution very easily. But the question is this a valid solution? Or is the solution a rational number? Is the solution an irrational number? Is this the limit? So those are the things that we can talk about. But I'm going to give you the other solutions as well, so that the picture is complete. Because I know when I don't talk about complex solutions, then some people get upset. I'm not going to give you numerical answers, but at least I'll tell you if there are any complex solutions to this. Okay, good enough, right? Okay, so the other solution is approximately 2.27. Don't worry about the details, you know, it's just you can use a calculator to find the other answer. Let's go ahead and also box that so that there's no difference between these two solutions. And then we have two complex solutions. Obviously, when you solve this problem, you're going to realize after you find one of the rational solutions, x equals 3, definitely you can divide both sides by x minus 3, and you can turn this into a cubic, which is easier to solve. Still complicated because there's a cubic formula, so on and so forth. Anyways, so we got two real solutions and two complex solutions. Fair enough. Now, the complex solutions are not going to help us because we're looking for a real solution, and because this limit is supposed to be a real number, right? If the limit exists, and it does, as you can see, we are getting some answers, right? Okay, and with these things, pretty much, it always does, doesn't it? Because this expression cannot get too large. Obviously, it's not going to approach infinity, as the number of radicals or whatever the pairs approach infinity, if you think about it. And I'll show you some comparisons. So let's go ahead and dig deeper into this, because I got like two candidates, and I want to know which one is more likely to be the limit. So let's go ahead and take a look at it from another perspective. Now, we defined our sequence as follows. A sub n plus 1 is equal to that, and a sub 1 is 2 root 2. So at least we know the first term, and 2 root 2, by the way, is about 2.8. Is that good enough? I mean, if you use 1.4. So it's about 2.8. So this tells us that the first term is 2.8, and two of the values that I got for limits, one of them is at 3, one of them is 2.2, but 2.27. 2.27 is less than 2.8, so that's kind of suspicious, but let's go ahead and verify this. So here's what I can look at. I can basically just expand a little bit, kind of like find the second term here. I'm not going to find it numerically, but I'll show you some comparisons. So this expression obviously is the square root of 7 plus the square root of 1 plus 2 root 2. As you know, 2 root 2 is our first term. This is our second term. And obviously, we can safely say that this expression here, 2 root 2, is less than 3, right? Because it's about 2.8-ish, and obviously, it's 2 root 2 is less than 1.5, so 2 root 2 is less than 3. And so this expression is basically less than the square root of 7 plus the square root of 1 plus 3, right? Because this is an increasing function. So that's what we get. But this is equal to 2. 7 plus 2 is 9, so this is equal to 3. Now, what does that tell you? It tells you that the second term is less than 3, right? Well, the first term is obviously less than 3 as well. We start off with 2.8-ish. But our terms are going to increase, because as you add more and more 7s and 1s to this, obviously, this is going to be an increasing function. And you can also prove that using calculus, but we don't need to get into that. Anyways, so to keep a long story short, the limit that works here in this case is going to be x equals 3. This is not going to be a valid answer, because our terms start with something like 2 root 2, and they're increasing. Therefore, 2.27 something cannot be the answer. Therefore, the answer is going to be x equals 3. And let me go ahead and give you the factors of this expression as well. When you find out that x equals 3 is a solution, you can also write our expression like this, and that's our cubic, which gives us a real solution and a complex solution. And so therefore our answer to this expression is just going to be, so if you rewrite the expression here one more time, the square root of 7 plus the square root of 1 plus the square root of 7 dot dot dot, going on forever, is going to equal 3 in the sequence sense we talked about. All right? And this brings us to the end of this video. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.